Problem number 35. 3 root 8 times 4 root 2. Anytime you're multiplying radicals, we know that we can multiply the term in front of the radical and then multiply the radicals themselves. Because remember, what's really taking place here is we have 3 times root 8 times 4 times root 2. And the order here doesn't matter because the commutative property tells us we can rearrange the order of any terms that are being multiplied and we'll get the same solution. So I can rewrite this as 3 times 4 times root 8 times root 2. Where I'll go ahead and multiply my 3 times 4, which is 12. And I'm going to simplify root 8. If I factor out a root 2 times root 4, I'll notice two things here. We've already dealt with our 3 and our 4. That multiplied to 12. Now I have the root 4. Square root of 4 is 2. So that takes care of that term. I'm left with the square root of 2 times the square root of 2. Now just an aside, let's remember what that means. That means 2 to the 1/2 power times 2 to the 1/2 power. And our product rule tells us that when we have the same base, which we do, we can add the powers together. So that would equal 2 to the 1st power. So anytime we multiply the same square roots together, we end up with a simplified answer, which is the value inside the root by itself. So those two together will simplify down to 2. So 12 times 2 is 24 times 2 is equal to 48. And that one cleaned up nice and pretty. Problem 36. Root 15 times root 15. Well, again, we just talked about anytime you multiply two radicals with the same value, they simplify down to the term in the radicand. So that would simply be 15. Problem 37. 3 root 27 times 2 root 12. So again, I'm going to multiply 3 times 2 times root 27 times root 12. Notice I left myself a little bit of space for the radicals so that when I'm simplifying them, I can write out their factors. 3 times 2 is 6. Root 27 is going to be a combination of root 3 times root 9. So we should be seeing, hey, I'm going to be able to take the square root of 9 and that'll pull something out of a radical. Square root of 12 gives us root 3 times root 4. So I'm going to drop some terms down. I have 6 times my root of 9. Square root of 9 is 3. Times my root of 4. The square root of 4 is 2. And then we have left the square root of 3 times the square root of 3, which is simply 3. So we have the solution, 6 times 3 times 2 times 3. Well, that equals 108. Problem 38. Negative 3 root 12 times 3 root 8. At some point, we're going to start to get used to certain roots simplify down to the same solution every time. So the square root of 12 seems to be simplifying down to 2 root 3, because I end up with the square root of 4 times the square root of 3. The square root of 4 simplifies out a 2. So we're going to go ahead and advance negative 3 times 2 times root 3. And the root 8, which we've seen several times, simplifies out a root 4 times root 2, which ends up 2 root 2. So we will pull out a 3 times 2 root 2, where I can rewrite this as negative 3 times 2 times 3 times 2 times root 3 times root 2. And so I have negative 36, and both my root 3 and my root 2 are in prime numbers. And so they're not going to factor down any further. And since neither one of them are the same value as another, they're not going to simplify any further. So at this point, we can put them back together. Root 3 times root 2 is root 6. And that will be our final simplified solution. Problem number 40. Negative 3x to the negative third, y to the negative fifth, z to the negative seventh. This is all getting multiplied by 2x to the fifth, y to the third, z to the negative ninth. Now again, remember that multiplication has the commutative property, which tells us the order doesn't matter. So I'm going to come into this problem and rewrite it, taking out first my coefficients, or my integers, sorry. So negative 3 times 2. Then I'm going to start pairing like terms. X to the negative third times x to the fifth, y to the negative fifth times y to the third, z to the negative seventh times z to the negative ninth. And hopefully you're noticing the reason why I'm doing that is because since I have all these terms next to each other that have like bases, we'll be able to use our product rule quite a bit. So negative 3 times 2 is negative 6. X to the negative third times x to the fifth. That's the same thing as saying x to the negative 3 plus 5. Well, negative 3 plus 5 is 2, so we simplify down to x squared. Y to the negative 5 plus 3 will give us a simplified answer of y to the negative second power. Z to the negative 7 times z to the negative ninth gives us z to the negative 16th power. Now we can get rid of our negative powers, not our negative integers. Negative integers are just negative integers with positive powers, so there's no reason to do anything with that negative 6. It'll stay in the numerator. Negative 6, the x squared already has a positive power, so it will stay in the numerator. Over my y to the negative second power, it has a negative power. We talked in class about it having a negative attitude. So we're going to put it down in the basement where it will hopefully have a positive attitude. The z also has a negative attitude. We're going to put it down into the basement where it will have a positive attitude. So we end up with negative 6x squared over y squared z to the 16th. You'll notice this is the solution for both problem 39 and the simplified solution for problem 40. So for problem 40, we then need to plug in values for these variables. So off to the side, I will say is equal to negative 6. Our value for x is negative 3, so negative 3 squared over our value for y is 0. Well, 0 to any power is still going to be 0, which means we're in an interesting point here, because I can plug in a 2 to the 16th power, but 0 times anything is going to be 0. So I'm going to get 0 in my denominator, and it doesn't matter what I put left in my numerator, because anything divided by 0 is going to give us no solution. So at this point, we're done with the problem. Problem 41, 5 to the y power times 15 to the negative z power. Now I don't like having a negative power, so we're going to make the power positive, and that will give us 5 to the y power over 15 to the z power. And then we can plug in our terms. Again, y was a value of 0, so that will equal 5 to the 0th power over 15 to the 2nd power. Well, 5 to the 0th power is equal to 1. 15 squared is equal to 225. And so we now have our simplified answer of 1 over 225. 42, 3x to the y plus square root of 225 raised to the y minus 2. I'm going to plug in what we know. 3 times x, our value of x is negative 3. And x is being raised to the 0th power. Plus the square root of 225 raised to the y, well, that's getting raised to the 0th power, minus 2. So let's clean this up a bit. Negative 3 to the 0th power. Well, that's 1. So we're left with 3 times 1 plus, it really doesn't matter what the square root of 225 is, even though we know it's 15. Since the square root of 225 is being raised to the 0th power, that's going to simplify to 1 minus 2. So we then have a 3 plus 1 minus 2, which equals 2. Problem 43. Home Improvement had their, had 3.5 times 10 to the 6th viewers for their first episode and 8.5 times 10 to the 7th new viewers for their second episode. How many viewers did they have overall? Now, I told you in class that sometimes it's a little bit more challenging to understand what the question's asking when we're dealing with these long scientific notation terms. So I could rewrite that question putting any numeric value in for the scientific notation just to be able to understand what operation is needed. So I could say something like Home Improvement had 5 viewers for their first episode and 4 new viewers for their second episode. How many viewers did they have overall? Well, that becomes much more simple for me to say, oh, I just need to add 5 plus 4 and end up with 9. So the operation that's taking place is addition. I'm adding the quantity of viewers. So we have 3.5 times 10 to the 6th viewers. And that is getting added to 8.5 times 10 to the 7th viewers. So now we're going to get our powers to the same value. I'm going to do so by moving my decimal 1 to the right, which will reduce my power by 1. So it's going to give me 3.5 times 10 to the 6th plus 85 times 10 to the 6th. Where we treat this like we would factoring, we now know that I can add the integer term, and I can then keep the base and its power the same. 85 plus 3.5 gives me 88.5 times 10 to the 6th power. 88.5 is not quite yet in scientific notation, so I'm going to move the decimal to the left one and get 8.85 times 10 to the 7th power. If you wish, you could certainly take this value and represent it in standard notation. That would look something like 885 and 5 more zeros. So 88,500,000 viewers. 44. Leanna United soccer team played their final game this past week and grossed 2.8 times 10 to the 15th dollars. Their first game only grossed 7 times 10 to the 4th dollars. How many times greater were their funds from the last game than the funds from the first game? So again, maybe a little bit more challenging to think through what the question's asking, but I could adjust it. Their final game this past weekend was played and grossed $8. Their first game only grossed $2. How many times greater were their funds? Well, that makes it a little bit more reasonable for me to think, oh, I need to divide 8 by 2. Because if I divide 8 by 2, I end up with 4. 8 is 4 times greater than 2. That makes sense in light of the information in the problem. So our operation that's taking place is obviously that we're going to divide the final game's gross, which is 2.8 times 10 to the 15th, by the first game's gross, 7 times 10 to the 4th. So 2.8 divided by 7 gives me 0.4. And since I have the same base in both the numerator and the denominator, we can subtract their powers. 15 minus 4 is 11, so times 10 to the 11th power. Not quite in scientific notation yet, so we will move the decimal to the right 1 unit. When we move the decimal to the right 1 unit, that decreases the power, so times 10 to the 10th power. Again, we could express this in standard notation by writing our 4 and moving our decimal now 10 places to the right. So since we already have a whole number, that's going to be adding 10 zeros. 1, 2, 3. Go back and add my commas. And we see that we have $40 billion. Oh, sorry. 40 billion times greater. Now, obviously, I made up these numbers. These were just for examples. Not likely to be 40 billion times greater. It's more likely that the first game and last game sales were closer together and would have had a little bit more reasonable amount of difference. But this was to get the point across on how to solve the problem, so you should have accomplished that. 45. An Ash's shuttle descends at a rate of 5.3 times 10 to the third miles per hour for 1.4 times 10 to the first hours after its final mark for descent. How far did the shuttle travel during descent? Well, we have 5.3 times 10 to the third miles per 1 hour. You should remember back from your math last year that this is what we call a unit rate. It's a quantity of miles per one of some other unit. And so we're also told that it descended for 1.4 times 10 to the first hours. So we should be able to recognize, again from last year, you did some dimensional analysis, which was converting units. If we multiply by 1.4 times 10 to the first hours, then we would end up with units that will cancel themselves out, much in the same way that when you have cross simplification, you can simplify terms that are being multiplied together. So now this simply leaves me with 5.3 times 10 to the third miles times 1.4 times 10 to the first. And we're going to end up with a solution that represents a quantity of miles. Since we're multiplying, I can multiply the decimals, then multiply my powers. 5.3 times 1.4 gives me 7.42 times 10 to the fourth power. This is already in scientific notation, so we can say 7.42 times 10 to the fourth miles, or we can write it in standard notation, 742. I use 2 of my decimal places there for 2 of my powers, so I need 2 more zeros. So 74,200 miles. We made it nearly to the end. Problem 46. Problem 46. X to the negative fourth times y to the 12th over x to the 6th times y to the negative fourth. All of that is getting raised to the negative second power and then getting added to the square root of 144 over 36. Couple of things taking place in this problem. We have a lot of our exponent rules. So the first thing I recognize is that I have a negative power outside the parentheses. I'm going to go ahead and distribute that negative power to every term inside the parentheses. So x to the negative 4 raised to the negative second. So we'll multiply those powers together, which will leave me with x to the 8th power. And this is why I go ahead and do it, because it can be rather confusing to try to apply your negative exponent rule and flip things around and then realize that you're changing the powers and flipping them again. So by going ahead and applying your power to power rule and getting rid of that parentheses term, I just think it simplifies things. So y raised to the 12th raised to the negative second gives us y to the negative 24 over x raised to the 6th to the negative second would be x to the negative 12. Y raised to the negative 4 times negative second would be y to the eighth. I'm going to work with one term at a time, and then we'll come back and catch this other term. X to the eighth, 8 is already a positive power. And now, before I do anything with that y, I'm going to look to see if there's any other x's in this problem that I can deal with. There's x in the denominator, and it's got a negative power, so that negative power is going to become positive if I bring it upstairs. Well, now I'll start to deal with the y's. And I notice that the y in the numerator has a negative power, so it will become positive if I send it downstairs. The y to the eighth power is already positive, so I'm going to leave it alone. Again, we're going to continue to simplify this one term, and then we'll go to attack the other one. X to the eighth times x to the 12th. We have our product rule, so we will add the powers. X to the 8 plus 12 is x to the 20th over. Again, we have same base with powers. Y to the 24th times y to the 8th gives me y to the 32nd power. Well, that is as simplified as this term on the left gets. Let's go back and clean up the one on the right. Square root of 144 over 36. We should realize that that can clean up into the square root of 144 over the square root of 36. In which we should see, oh, square root of 144, that's 12. And the square root of 36, that's 6. And now I recognize that 12 over 6 is simply 2. So I'll bring down my final answer, and we end up with x to the 20th power over y to the 32nd power plus 2. Problem number 47. 14x to the 4th power, y to the negative 12th power over 1. All of this is getting raised to the negative 2nd power plus the square root of 38. Oh, that's one big square root. Square root of 38 over 196. Again, I'm going to work one term at a time, so I'm going to start with my term on the left. Remember that the 14 has a power of 1. So I'm going to apply my power to powers rule. 14 to the power of 1 raised to the power of negative 2. So 1 times negative 2 is negative 2. Will leave me with 14 to the negative 2nd power. X to the 4 times negative 2 would be x to the negative 8 power. Y to the negative 12 times negative 2 would be y to the 24th power. All over 1 to the negative 2nd power. We'll continue to simplify the term. 14 to the negative 2nd power is going to come down into my denominator. So 14 squared. X to the negative 8th power is going to come down into my denominator. X to the 8th power. Y to the 24th has a positive power, so it can stay upstairs. And then 1 to the negative 2nd power. It needs to come upstairs to make its power positive, but then we end up with 1 squared. And 1 squared is 1 times 1. And 1 times anything is whatever term is there, so we're simply going to have our y to the 24th power. And now we can simplify one more step. Y to the 24th over 14 squared is 196. X to the 8th power. Eventually, I know I'm going to need to add whatever my simplified value of my second term is, so let's go back and look at that one. We have the square root of 38 over square root of 196. Square root of 38. Square root of 38 is a factor of 2 times 19. And 2 times 19, both of those are prime numbers, so it's not going to simplify at all. The square root of 196, well, that's 14. So that's as simple as that term on the right is going to get. So we end up with square root of 38 over 14. And that's going to be our final solution for that problem. Y to the 24th power over 196 x to the 8th plus square root of 38 over 14. The last two answers on your study guide you should be able to look up from the guided notes that were provided in class, because those were provided for you word for word, and you've been using them quite a bit throughout the course of this study guide. So hopefully that has been enough information to help you be successful in getting ready for this test. It would probably be a good idea to review back over some of your homework assignments and or maybe print off a couple of new ones just to make sure that you are strong enough in the areas that you felt weaker. Again, if you have any questions, I will be available on study guide day to answer questions, and I will be available Tuesday morning at 8:15 to help answer any questions.